Okay, so now let's talk about the properties of sinusoidal graphs. So, there's three main ones. We're going to have the midline, we have the amplitude, and we have the period. So, what do these each mean? Well, let me just draw a sinusoid for you guys. Okay, something like that, okay? So, let's talk about the midline. Well, the midline is going to be the imaginary line that runs directly in the middle of the sinusoid, right? Which is, and how you can find this is just the average of a maximum point and a minimum point, okay? It just lies directly in the middle. And from the midline, you can determine the amplitude. And the amplitude is basically how much the maximum point is above the midline or how much the minimum point is below the midline. The period is basically the length of y value, so how long it has to be before it's in the same spot of the hump, okay? So if I were to find the period of this graph, I would say, okay, well, we have the maximum point here and the maximum point here, so that's going to be easy. I'm just going to find the length from one maximum point to the other. And it doesn't have to be at the maximum point. It could be right here, the length between there and there, so I have to find the length between there. But remember, it's not the length from here to here. It's not the length from the same y value to the same y value. It's to the same spot in the humps of the waves. So now let's talk about how an equation, a sinusoidal equation, is set up. So let's do y is equal to a times, and this can be either cosine or sine. I'm just using cosine for now. Cosine of b times x minus c plus d. And I'm going to explain each of these parts to you. So now, let's look at this equation and break it apart. So we have a. Okay, well, what does a mean? Well, the absolute value of a is equal to the amplitude. And why I say absolute value is because it doesn't really matter if it's a positive or a negative. It could be negative a or positive a. But it is important to note whether it's positive or negative, because if it's negative, it means that the graph is flipped over the x-axis, like I've talked about in one of my previous videos about transformations of graphs. So the absolute value of a is the amplitude. And again, I said the amplitude is basically how much the maximum or minimum point deviates from the midline. Okay, and now let's look at the next part. Cosine is pretty self-explanatory, and it's going to be cosine of b times x minus c. Okay, well, let's talk about b. What is b? And the absolute value of b is used in finding the period. So it's not equal to, but it can help you find the period. And again, why I say absolute value is if it doesn't matter if it was positive or negative. But again, it is important to note, because if it's negative, right, then it's going to flip the graph over the y-axis. And again, I have talked about this in a previous video about the transformations of functions. So how can I use b to find the period? So normally the period is 2 pi radians. 2 pi radians. How I can find the period of this function is by dividing 2 pi by the absolute value of b. And I'll explain why. So if we have our unit circle, period in terms of the unit circle is from any point how many radians does it take for it to end up in the same spot, which, like I said, for the unit circle is 2 pi radians, or 360 degrees. Let's say b is equal to 3, okay? Well, that means that I get in a full rotation, I guess, or get back to the same point 3 times faster. So that means that the period is going to be 3 times less. So I would divide it by absolute value of 3, which is 3, right? And so then I'd get the period 2 pi divided by 3, right? So now let's move on, okay? Let's talk about c. So what is c? And again, talking about my, going back to my transformations of functions, c is how far it is moved to the right, okay? So it's how many x values it is moved to the right. Okay, well, let's say for a cosine function, right, and it intersected at 1, right? So let's say, I don't know, maybe here. Okay, that was our 1, okay? Well, if you move it over 3, right, it's going to be here, and you'd have to have your x value equal to 3 for it to be 0, right? Or at least for your x to be 0. And so then you'd write that as x minus 3, right? So that's the logic behind it. And if it was negative, it would just be plus that number, right? Because if I have x minus negative c, I just make it positive, right? So it would just be x plus c. And finally, let's cover what d is. D is just the y value of the midline. So for a normal function, it's like y is equal to cosine of x, it's not nothing's being added to it because the midline's at 0. I mean, technically it's plus 0, but by default the midline is at 0. So, if it was equal to positive 5, it would be at, y level 5. If it was negative 7, it would be at y level negative 7. So, I really suggest experimenting with this on your own or find example problems to practice with because, this takes a lot of practice to get good with, and for my future videos, this is going to be a very important concept to learn. Okay guys, so thanks for watching. So this video we covered sinusoidal waves, and next video we'll talk a little bit more about applying these sinusoidal waves to more realistic problems. So, thanks for watching. Peace.